Okay, so we're going to be talking about piecewise functions. A piecewise function is a function defined by two or more equations. Each piece of the function applies to a different part of its domain. All right, so for this example, they're written kind of funny. So they have this f of x equals and then this big kind of brace right here. So this is one part, one piece, all right, and this equation is another piece, all right. So my graph is x minus 1 if x is less than or equal to 0. So that means like the left side of my coordinate plane. So if I look at this, I have the equal to bar right here, which means that's an enclosed circle. So right there, I have a dot. So in other words, when I plug in 0, 0 minus 1 is negative 1, and I have a dot there. And it's closed in because of this equal to bar. All right, so then when I plug in negative 1 minus 1 is negative 2. So negative 1, negative 2. So I've created dots. This is going to continue for every value where x is less than or equal to 0. Okay? Then I have this piece of my function, which is x squared plus 1. And if you'll recall, okay, when we have a degree of 1, that's going to be linear, a line. We have a degree of 2, that's a parabola. But we're only at x squared plus 1 if x is bigger than 0. So I want to start at 0. All right, 0 squared is 0, plus 1 is 1, so 0, 1. But since I don't have the equal to bar, I'm going to put an open circle because it's not included. Okay, and then I would just continue to pick 1 squared plus 1 would be 2. So 1, 2, 2 squared plus 1, 2 squared is 4, plus 1 is 5, so 2, 5. And then put that because it's going to keep going for every x value that's greater than 0. Okay? So we're going to evaluate a couple of x values. So it says evaluate function f when a, x is equal to 0, and b, x is equal to 4. So I have to pay attention to which piece I'm looking at. So this is telling me which part I'm supposed to be paying attention to. All right? So I look at this, x is 0. Well, I know that x minus 1 is the function if x is less than or equal to 0. I know that x squared plus 1 is my function if x is greater than 0. So since I'm looking for when x is 0, well, that is only if x is less than or equal to 0. So I'm going to use this equation. So I say f of 0 is equal to, and then I'm going to plug into this piece right here, 0 minus 1. So f of 0 is equal to negative 1. All right, so if I look at part B, when x is 4. So I look at 4 and I say, well, is 4 less than or equal to 0? No, so I'm not looking at this piece. Is 4 greater than 0? The answer to that is yes. So I will use that second piece. So I'm looking for f of 4. I'm just going to take 4 and plug it in for that x right there. So 4 squared plus 1, which gives me 17. So let's do a few more of these. This time I have 3 pieces, okay? So when x is less than negative 2, I will use this piece. When x is in between negative 2 and 5, also including those values because there are equal to bars there, then I will use this piece. When x is greater than 5, I will use this piece. So if I'm looking at negative 8, I have to figure out where that fits. Is negative 8 less than negative 2? Yes, it is. So I have negative 8 plus 4. I'm literally just taking that x out, putting a negative 8 in its place. Negative 8 plus 4 is negative 4. So f of negative 8 is equal to negative 4. And I do want you to format your answers like that. All right? 0. So let's see where 0 fits in these domains. Is 0 less than negative 2? No. Is 0 in between negative 2 and 5? Yes. So I've got 2 to the negative 0. Well, you can't really have a negative 0, so this is literally just 2 to the 0. And anything to the 0 power is 1. Okay? So now I'm going to look at 5 and see where 5 fits in. Is 5 less than negative 2? No. Is 5 between -2 and 5? And remember, I am equal to 5 here as well. This is where 5 fits. 5 doesn't fit here because 5 is not bigger than 5. But 5 is less than or equal to 5. So that gives me 2 to the -5th. All right, and you can just plug that into your calculator. That's fine. It's going to give you 1 over 32. If you want to think about it, this would be, I would need to flip it to get rid of this negative, so this would be 1 over 2 to the +5, and 2 to the 5th is 32. All right, and this last one, -2. So is -2 less than -2? No, it's equal to, but not less than. So then I look here and I say, okay, well, I see that I can be equal to -2 here, so this is the one I'm using. I have 2 to the -2. You have to be careful there because there's already a negative right here, and then I plug in a -2, which is actually going to make this 2 to the +2, which gives us 4. Oh, we have 2 more. All right, so I look at 3. Well, is 3 less than -2? No. Is 3 between -2 and 5? Yes, it is. So I'm going to plug in 3 for x. So that gives me 2 to the -3, which would be the same thing as 1 over 2 to the +3, or if you so choose, your calculator will tell you that's 1 over 8. All right, and the last one, 10. So is 10 less than -2? No. Is 10 between -2 and 5? No. Is 10 greater than 5? Yes. So I'm going to use this equation and plug in 10. So I have 3 times 10 to the 2nd power. So 10 squared is 100 times 3 gives you 300. And again, you can plug those into your calculator if you so choose. All right, so let's take a little time to graph these. So we have 2 pieces, right? We have 2 equations. So let's start with the first one. We have y equals x squared minus 1. So let's create a table of values here. I'm always going to start with this number. All right, and then I'm going to choose numbers that go along with this statement. X is less than 0. So that means I need to pick numbers that are negative. All right, so I'm going to start with 0. Even though 0 is not included, we still have to start there because everything that butts up next to 0 is also included in this statement. So instead of not including, I'm going to include it, but it's going to be an open circle here. So if I plug in 0, 0 squared minus 1 is equal to -1. And then I'm going to choose a couple more. So let's plug in -1. Remember, you need to pick numbers that go with this statement right here, numbers that are less than 0. So I have -1 squared minus 1. Now you have to be careful because if you don't put parentheses here and you're using your calculator, it's not going to square that negative. All right, so be careful. -1 squared is 1, minus 1 is 0. All right, let's do another. So let's do -2. So I'm going to plug in -2. Squared minus 1 equals, not 0, that's 1. All right, -2 squared is 4, minus 1 is 3. And let's do one more. Let's do -3. So -3 squared minus 1. So I get 9 minus 1 is 8. And then I think if I pick -4, that's going to be way off my graph, all right, because that would be 16 minus 1 is 15, and I don't have that many spaces on here, okay? All right, so I look at this, and I'm going to plot these points. Now remember, this is going to dictate whether you have an open circle or closed. I don't have an equal to, which means that this first point is going to have an open circle. And again, that's just because I don't have the equal to bar underneath there. So I'm going to go to this point, 0, -1. So left, right, 0, down 1. I'm going to put an open circle. And then I'm going to plot the rest of these points. -1, 0, -2, 1, 2, 3, -3, 4, 5, 6, 7, 8. And I'm going to draw all of those together. So in other words, I'm here, don't color in that circle, and this is going to extend up, put an arrow on the end. So that's one piece of my graph. Now I look at the other piece. So this is y equals 4. Well, if you remember about linear equations, okay, I already knew this one was going to be curved because it's a parabola, okay, it's quadratic. This is linear, okay, but this is just a flat line, right? So it doesn't matter, you know, what values I pick for x. Every time I pick an x value, the y value will be 4. But I'm going to start at 0. So when x is 0, y is 4. Y is always 4. All right, so I'm going to go up to 4. 1, 2, 3, 4. And since there's an equal to bar, I'm going to put this closed circle. Okay? All right, when x is 1, y is still 4. When x is 2, y is still 4. 4, 4. It's always 4 no matter what the x value is. All right, and so this will extend to the right because it's everything greater than or equal to 0. And there's the graph to my piecewise function. Now let's talk domain and range. So if we talk about domain of this piece right here, I'm starting left. This just continues to go up and out. So that would be negative infinity. And it would go all the way to 0. This piece stops at an x value of 0. All right, but at 0 I have an open circle, so I need to have a parenthesis to show that 0 is not included. When you look at the domain of the piece on the right, it starts at an x value of 0, but that x value of 0 is included, so I need a bracket, 0, comma, and then this continues all the way to the right, so that would be all the way to infinity. So let's talk about range of the piece on the left. Range is how low to how high. So if I think about the lowest point here, that would be at -1. But at -1, I have an open circle. So I'm going to put a parenthesis to show that is not included. And then this graph continues to go up to infinity. Infinities always have parentheses. Let's talk about range of the other part. Well, I don't go higher or lower than 4. Right? I'm just at 4, so my range is y equals 4. All right, let's do another. So we've got y equals 2x plus 1. So that x has a power of 1. That's my highest power, so this is linear. Okay, so it's just going to be a straight line. So I need to be picking x values that are less than or equal to 0. So remember, we always start with 0, and then we pick those x values based on what that statement is telling us. So I'm going to start with 0. So I have 2 times 0 plus 1. That would be 1. So a y value of 1. All right, then I'm picking numbers that are smaller than 0. So let's go with -1. 2 times -1 plus 1. So that would be -2 plus 1 is -1. And we'll do -2. I'm going to keep picking until I can't fit these points on the graph anymore based on what graph I'm given. 2 times -2 is -4 plus 1 is -3. So when I plug in -2, I get -3. Then I have 2 times -3 plus 1. -6 plus 1 is -5. And maybe by now you see a pattern here. I am just subtracting 2 every time, so -4 would be -7, -5 would be -9, so on and so forth. So remember, since I have the equal to bar, that means my first point here is going to have a closed circle. All right, so I go to this point, 0, 1, and I have a closed circle there. Then I'm going to plot the rest of these points. -1, -1, -2, -3, And then we have -5, -7, -9. So this just goes in a straight line this direction and keeps going. Okay? So there's one piece. Then I have y equals x squared. So we always start with whatever number they're showing right here. So I'm going to start with 0. 0 squared is equal to 0. And then I'm going to choose numbers that are bigger than 0. So 1. 1 squared is 1. 2 squared is 4. So when I plug in 2, I get 4. All right, 3 squared is 9. So when I plug in 3, I get 9. If I do 4, I'm going to get 16, and that's way off my graph. All right, so I have to think about what my first point is going to be, open or closed. There's no equal to bar here. All right, so that means my first point here will have an open circle. So I go to 0, 0, and I'm going to put an open circle right there. Then I plot all my points. 1, 1, 2, 4, 3, 9, which makes part of a parabola. All right, and just so you know, since these are functions, okay, I will not have a closed circle on top of an open circle. Like one will be open, one will be closed, okay? So you shouldn't have like a closed and a closed right here. All right, so let's talk domain and range. So for my domain, I'm going to look at the left-hand side first, so this piece right here. This continues down to the left, so this starts at -infinity because it continues to the left. And then as far right it goes is 0. And if you look at this piece right here, this is the piece we're talking about, it stops right here at 0 and it is closed. So I need to put a bracket right there. Okay? Let's talk about domain of the other piece. It starts at 0, but it's an open circle, and it will continue to the right. So I'm going all the way to infinity, parenthesis. Let's talk range. This left piece, all right, just goes down, 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 down. So it starts at -infinity, and it's going to go all the way up until it gets to a y value of 1. Since there is a closed circle right there, we will have a bracket. Look at the other piece. We're talking how low. So this goes and starts at 0, open circle, and goes all the way up, so all the way to infinity. All right, in example 3, identify the intercepts of the graph of the function and the intervals on which the function is increasing, decreasing, or constant. So if we look at example 3, let's talk about intercepts first. Okay, so we only have one x-intercept, which is at -1, 0, and we have one y-intercept. Now you'd like to say that there are two, but does this one really count as a y-intercept? No, because there's an open circle there. This is the only one that actually touches the y-axis. So that would be at 0, 4. All right, so we'll write that down in just a second. Then I'm decreasing. So remember, we read left to right, left to right. So if I read this and I look at this side of my graph, this is going down, correct? So that would be decreasing. And when do we decrease? We decrease when our x value is less than 0. So x value less than 0 is when this is decreasing. Are we increasing anywhere? Meaning, are we going up? No. Constant means when we remain flat. Okay? So if I look at this, I am constant when x is greater than 0. So to write all of that down, we have an x-intercept at -1, 0. We have a y-intercept at 0, 4. We are decreasing when x is less than 0, and we are constant when x is greater than 0. All right, number 6 says identify the intercepts of the graph of the function and the interval on which the function is increasing, decreasing, or constant. So the same thing. All right, so if I read, let's do intercepts first. So I have an x-intercept right here. So x-intercept, and that point would be -1, 0. Sometimes when I ask for x-intercept, if you're doing something online, you would just put in -1. All right. Y-intercept, all right, we have 2 points where it looks like we're crossing, but this one doesn't count because it's open. So we're going to look at the closed circle. That's at -1, so 0, -1, or it might just want you to say -1. All right, I see that if I read left to right, this is going down when x is less than 0. And I see that this is going up when x is greater than 0. So I am decreasing when x is less than 0, so everything on the left side, and I am increasing when x is greater than 0. So let's look at number 7. Got lots going on, okay? So let's look here. Looks like I have 2 x-intercepts. I have one here, and I have one here. All right, so I have x-intercepts at -2 and 4. All right, for a y-intercept, it looks like I'm only crossing my y-axis at one point, and that would be right here. So that would be a y-intercept at 2. All right, and then if you look at this, this piece is actually decreasing and then increasing, right? So first, I'm going to list my decreasing. So look at the point where it stops decreasing and starts increasing. That's at an x value of -2. So I'm going to say I am decreasing when x is less than -2. All right? Now, there's no other decreasing parts on here. This is increasing, this is constant, this is increasing. So I have 2 spots of increase. So I'm going to have 2 statements for that. So I am increasing when x is, same spot right there. This stopped decreasing here and started increasing. So when x is not completely greater than 2, but just in this one little spot. So from here to here. So in between -2 and 1, right? So I actually have a statement. This would be between -2 and -1, right? Just between these 2 spots right here. Then I'm also increasing from here to infinity, right? So when x is greater than, now what is the x value right here? It tells you that that's 1, right? 1. So when x is greater than 1. And then your constant between here and here. So that would be -1 and +1. So when x is in between -1 and 1. Remember, you always go smallest on the left, biggest on the right. All right. So number 8, we're talking about step functions. So a step function is a piecewise function defined by a constant value over each part of its domain. All right. So the graph of a step function consists of a series of line segments. So, and they call it a step function. I mean, it looks like steps, right? Like you're going up the stairs. So it's saying that y is 2 when x is between 0 and 2. So I'm equal on the 0 side, but I'm not on the 2. So that's why I'm enclosed when x is 0, open when x is 2. I'm 3 when x is between 2 and 4. So I'm at a y value of 3 between 2 and 4, equal on the 2 side, not equal on the 4. So closed, not closed. Okay, so closed and open. And then it just keeps going, all right? So we're going to do a problem here. It says you rent a karaoke machine for 5 days. All right, 5 days. So I'm going to have 5 spots here. All right, 5 spots. 5 days. The rental company charges $50 for the first day. So on day 1, you're paying $50. Okay. On day 2, all right, and every day after that, they're charging an additional $25. So if on day 1 I'm paying $50, day 2 I would be paying $75. Day 3 I would be paying $25 more than that, which would be $100. Day 4, $25 more than that, and day 5, $25 more than that. Okay? So this is day 1, right? So that's if I'm between 0 and 1. Now you need to decide where your equal to bar goes. If I haven't even done a whole day, would I be paying anything? No. So 1 day I'd be equal to, right, 1 day. So my equal to bar is going to be on the right-hand side of all of these. So this is day 2, which means that goes from day 1 to day 2, but this is day 2. Okay? This would be between day 2 and 3. But this is actually day 3, right? So in other words, if you think about this as day 2, 2.5, you'd still be in the 3rd day, right? So equal to bar. This would be day 4. Oops. And this would be day 5. All right. So this will be our number of days. Okay. And this over here will be the total cost. All right, so let's count by 25. So we have 25, 50, 75, 100, 125, 150. And we have 4 days, no, 5 days. 1, 2, 3, 4, 5. So anything in the first day, whether it's half a day, whatever, all right, I'm paying $50 between 0 and 1. So here's 0, here's 1. I'm at 50. I'm not equal at 0. I am equal at 1. And then you just connect those two. All right, I'm at $75 between 1 and 2. So here's 1, here's 2. Open circle, closed circle. I'm at 100 between 2 and 3. So open, closed, connect. Open, closed, connect. Open, closed, connect. All right. Number 9, a landscaper rents a wood chipper for 4 days. Okay, we have 4 days of stuff here. All right, the rental company charges $100 for the first day. So day 1, I'm paying $100. $50 for each additional day. All right, so day 2, I would be paying $150. Day 3, I would be paying $200. Day 4, $250. So if I asked you day 5, that would be $300, right? All right, this would be if. We have ifs on all these. If. This is day 1, right? So anything, half day, you know, whatever, 3/4 of a day. So if X is in between, now remember, this is for a whole day, okay? This would be between days 1 and 2. This is day 3. This is day 4. Okay? So this right here would be my days, number of days. And then over here, this would be my total cost. I know you guys are impressed with my ability to write sideways. So I have 4 days. And let's count by 50 since I'm going up by 50 every day. So 50, 100, 150, 200, 250. So between 0 and 1, open circle, close circle, I'm at 100. So I go up to 100. This is 0 and 1. Connect. I'm at 150 between 1 and 2. Open circle, close circle, connect. I'm at 200 between 2 and 3. Open circle, close circle, connect. At 250, I'm between 3 and 4. Anything over 3 days, right? And there you have it.